Hi there, I'm an avatar designed by Yili Lin, a health services research PhD candidate at George Mason University. Let's dive into today's topic, testing assumptions for ordinary regression in R. To ensure the model's appropriateness and reliability of results in ordinary regression in R, key assumptions to test before and after include linearity, independence, homoscedasticity, normality of residuals, and no multicollinearity. To ensure the relationship between predictors and the response variable is approximately linear before fitting the model, use a scatter plot to visualize their relationship. A linear pattern supports the assumption of linearity. If a clear, non-linear pattern appears, consider transforming the variables or using a different model. The independence of observations means that samples are independent of each other. Ensure random sampling and avoid repeated measures or clustering unless using appropriate models. This can be assessed through study design. Multicollinearity affects the stability and interpretation of regression coefficients, leading to inflated standard errors and difficulty in assessing each predictor's individual effect. Testing for multicollinearity beforehand ensures a more accurate model and interpretation. The variance inflation factor, VIF, is commonly used to detect multicollinearity in ordinary regression. Verify that the residuals have constant variance across predictor values by checking if they are randomly scattered around zero without patterns, such as funnel shape. The pattern indicate heteroscedasticity, suggesting that residual variance is not constant and may need corrective measures. To ensure valid hypothesis tests and confidence intervals, check if the residuals are normally distributed. A histogram of the residuals should show a bell-shaped curve, indicating normality. A QQ plot compares the quantiles of the residuals to those of a normal distribution. Points lying along the diagonal line suggest normality, while deviations indicate non-normality. To check for autocorrelation in residuals, use the Durbin-Watson test. Values around 2 indicate no autocorrelation, while deviations suggest potential issues with residual independence. Cook's distance is a common regression diagnostic that measures the influence of a data point. Higher values suggest potentially influential points. Log transformation can adjust for nonlinearity and stabilize variance when it increases with the level of the response variable, helping to achieve normality. To address multicollinearity, remove one or more highly correlated predictors. Or combine correlated variables into a single predictor. Or use regularization techniques such as lasso or ridge regression that can handle multicollinearity by adding a penalty to the size of coefficients. Investigate whether outliers or influential points are errors or valid observations, as outliers can sometimes provide valuable insights into the data. Apply transformations, such as log transformation, to mitigate the impact of outliers. Use robust regression techniques that are less sensitive to outliers. Refit the model after addressing outliers and influential points to evaluate changes in the results. Checking assumptions before and after regression is essential for valid results. Violations can lead to biased coefficients, incorrect hypothesis tests, and unreliable predictions. Addressing these violations improves the model's reliability and accuracy.